Hello everybody, my name is Mark Barrett with Blue Wireless. So today we're going to be talking about the various differences and merits of licensed exempt, or sometimes called unlicensed millimeter wave spectrum, as it relates to a number of commercial applications. For customers, the simple answer to that question is control. So if you take private networks as a very good example of a class of systems where customers wish to build a specific closed network for their own use. That could be in a factory, it could be on a railway line, it could be around an airport. Usually customers wish to control the performance, the parameters, and the access to that network, and often reluctant to hand that control to a third party like a mobile operator. So a key benefit of using equipment which is license exempt is that because they don't need to get a license from the government, they are free to build a network within their own boundaries of their installation, and control that network themselves. Now there are the possibilities of buying a license for licensed spectrum, but it's complex and not to be undertaken lightly. And some customers do that, of course. But I think if you're looking to build a private network with high performance, meaning a gigabit grade of connectivity performance, you need a lot of spectrum at low frequencies to do that, and that spectrum is very expensive. And clearly, if you avoid that cost by using licensing exempt spectrum, millimeter wave, not only can you control your own system, you can also get access to very high capacity spectrum and equipment to exploit that spectrum. So one of the interesting applications which complements 3GPP quite nicely is the deployment of small cells, particularly small cells which use 5G NR radios to increase the capacity towards smartphone users. The big problem is when you deploy small cells, particularly in dense urban environments in cities and so forth, it's often extremely difficult to provide access from the small cell back into the core network for internet connectivity, for example. And of course, if there is a fiber connection available, that's easy. You plug the fiber in and off you go. But usually there isn't, and the cost of putting a new fiber in a complicated urban environment is high, along with delays for planning and so forth. So a good use of unlicensed millimeter wave spectrum is to provide a wireless connection backhauled from each small cell back to the core network, and that accelerates the deployment of 5G in our small cells by reducing the time and cost of deploying where there isn't fiber today. So we have some discussions going on with operators in that regard. We have a few things going on, some of which are in the public domain. So, for example, we've recently been awarded additional funding to extend the scope of our Liverpool 5G project to include the connection of a network of 5G NR small cells using our millimeter wave technology back to the core network. And that complements the work we've done on building a network which is aimed at telehealth applications, where citizens of Liverpool can stay in their homes and connect with their doctors or consultants to have medical consultations on their particular conditions without having to travel to a hospital or a GP surgery. So the ability to do that at a city level, obviously, in these times of COVID, where people want to minimise their social contact, is extremely relevant. I think the other point to make is that the millimeter wave equipment that we deploy is small in form factor. We don't use high gain dish antennas, which can be a blight on the urban landscape in some people's opinions, and therefore the equipment is low profile for deployment at street level, and that's another important factor for the city authorities. there are some analogies, but then there are some differences. So if you look at what the European regulations state for Wi-Fi 6, what they're doing is to add roughly around 500 megahertz of spectrum between around 6 and 6.5 gigahertz, I believe, from memory. But the transmitter power levels they're allowed are very low. They're about 25 dBmi, so 15 dB lower than we can enjoy at a millimeter wave. So they're transmitting 15 dB lower. They've only got 500 megahertz compared to the 14 gigahertz we have at millimeter wave. And that 500 megahertz, by the way, is subdivided typically into a maximum of 160 megahertz, usually 80 megahertz channels. So whilst there are some similarities, the capability in terms of data rate and range is actually a lot lower than it is using the unlicensed spectrum at 57 to 71 gigahertz. So that translates directly to the benefits if customers want to transmit gigabits over a kilometer or so of range for a private network application. Okay, so clearly operators' main business model is to provide smartphones to customers and generate revenues off the back of monthly contracts and so forth. So that's not our business. We're not in that space. However, the operators also wish to deliver increased data rates to the same customers. And as I was explaining earlier, to do that, they need to deploy 5G small cells to make sure that they deliver the capacity where it's needed at street level close by the customers. And the problem then is, how do you get that data to the small cell to connect to the smartphone? So that's where we come in with our unlicensed millimeter wave equipment to provide that gap. So in a sense, it complements the delivery of increased data rates to end customers in highly dense small cell environments. We've been discussing mobile operators with end customers typically being smartphone users. However, there is another class of customers which I think is interesting, and that is domestic customers who want fixed broadband services. So typically today, these are delivered over telephone lines using ADSL or VDSL technologies, with fiber to the cabinet, with the short distance delivered over copper cable. And that's great, and I enjoy that at home, and it delivers about 40 megabits of capacity to end users. But as is well known, there was an initiative in the UK to increase the data rates that customers can enjoy to the gigabit region. And to do that, you either need fiber to the home, and that's difficult and expensive because, again, you have to dig up the streets, put the fiber into each house and so forth. Or you could use millimeter wave as a hybrid technology for the last mile connection. So you can create a fiber point of presence, a POP, which could say enjoy maybe 20 or 40 gigabits of connectivity back through a fat fiber pipe to the core internet. And then from that fiber POP, you can then mesh or connect using millimeter wave to each customer premises. So that's what's generally called a fixed wireless access model of delivery, but is one that could use unlicensed millimeter wave spectrum to complement fiber to speed up the delivery of gigabit grade connectivity for fixed wireless access, domestic broadband and business broadband. And in that regard, the independent ISPs play a part in deploying that technology to customers alongside the larger ISPs. Okay, so I hope this short video has helped to explain the differences between licensed and licensed and exempt, or unlicensed spectrum if you prefer. I think I've tried to position licensed exempt millimeter wave spectrum as being a very good resource to deliver gigabit grade connectivity for private networks, for fixed wireless and for small cell backhaul. And Blue Wireless is active in all these markets in varying degrees. And if you want to find out more information, please contact us.